All right, guys. So we're still on Unit 10, obviously. Stoichiometry, cool word. Day 2. So yesterday, or day 1, we did mole-to-mole ratios. Today we're going to use the mole-to-mole ratio and just add mass, which means grams, which means use your periodic table. Okay. So we're going to cover basic steps of how to do these calculations. And then I'm going to run through an example. So first is you need to convert the grams that you're given to moles. And you do that by using your periodic table, the molar mass. Its units is in grams per mole. You should remember this from Unit 8. Unit 8, we used molar mass all the time, which is grams per mole. You added up all of your atoms in your compound by using their corresponding molar mass in the periodic table. Then you had the total molar mass for that compound by using molar masses. Okay, so number 2, convert the moles of your known, so whatever you were given, to moles of your unknown, the one that you're looking for, using the mole-to-mole ratio that we did on day 1. So from there, whatever unknown that you now have, which will be given to you in the problem, then you convert that back to grams by using molar mass off the periodic table. So step 1, convert what you're given, grams, to moles. Then use step 2, convert that moles to your unknown moles by using your mole-to-mole ratio that we learned yesterday. Then step 3, convert that new moles to grams. If that confuses you, let me show you what I mean. So here's an example. What mass of silver chloride will react with 15 grams of aluminum? So I'm asking for a mass of silver chloride given a mass of aluminum. Well, how do I do that? Well, first you're going to have to write a chemical equation. And I'm just going to give it to you. It needs to be balanced. So I'm doing a tally system right here. And if you don't know how to do the tally system, you need to get with me or Mrs. Flint. I'm kind of running through it there real fast, but now it's totally balanced. Now, start with what you're given. You have 15 grams of aluminum. What am I looking for? I'm looking for the mass, which is grams, of silver chloride. So here's aluminum, and I'm looking for the mass of this guy, silver chloride. Here they are circled. I'm going to use that mole-to-mole ratio. There's 1 mole of aluminum for every 3 moles of silver chloride that reacts. So I have 15 grams of aluminum. How can I get to moles? This is a mole-to-mole ratio. The 2 circles, that's not grams. I first have to convert grams of aluminum to moles. So looking on your periodic table, aluminum has a mass of 26.98 grams per mole. And I did that by looking at the molar mass on the periodic table. Remember to round to your hundredths place. Now I have moles of aluminum. My grams of aluminum canceled out, 1 on top, 1 on bottom. I'm left with moles of aluminum. Is moles of aluminum what I want? No. I want grams of aluminum chloride. So I'm going to have to convert to first grams of chloride. To moles of silver chloride. So can I use a mole-to-mole ratio? Absolutely. For every 3 moles of silver chloride, there is 1 mole of aluminum. That's the mole-to-mole ratio that we used yesterday. Of course, the moles of aluminum go on bottom. Why? Because dimensional analysis, I want to cancel those out. So for every 1 mole of aluminum, there are 3 moles of silver chloride. Moles of aluminum on top, moles of aluminum on bottom, they cancel out. Now I have moles of silver chloride. Is that what I'm looking for? No, I want grams of silver chloride. Can I use my periodic table and add the two masses of silver and chloride together? Absolutely, because if I do that, that's 1 mole of silver chloride. So using your periodic table, silver is 107.87, chlorine is 35.45. I get a total of 143.32. So the moles go on bottom. My mass that I just added goes on top, 143.32 grams of silver chloride for every 1 mole. All I did was use my periodic table and add the molar masses together for silver chloride. Moles of silver chloride on top, moles of silver chloride on bottom. I'm left with grams of silver chloride. Is that what I'm looking for? Yes. Now you can plug and chug in your calculator. 15 times 3 times 143.32 divided by 26.98. And you'll be left with 239 grams of silver chloride. 3 significant figures, and it's labeled, so we are done. Let's do another example. What mass of oxygen gas would be produced from the decomposition of 37.2 grams of lithium chlorate? So lithium chlorate is LiClO3. They said decomposition, so I have something big, a compound, going down into simpler elements or other simpler compounds. In this case, lithium chlorate will decompose into lithium chloride plus O2. We need to balance it. Now it is balanced. Again, if you don't know how to do that, please use your tally system to make sure you get the right coefficients, because without the correct coefficients, you will get the mole to mole ratio incorrectly. Write what you know. Write what you don't know. I know I'm looking for grams of oxygen. Why? Because mass of oxygen gas. That's what I'm looking for. The mole to mole ratio that I'm using is lithium chlorate and, of course, oxygen. That's what I want. I'm looking for oxygen, but I'm given lithium chlorate. So I have 37.2 grams of lithium chlorate. I'm going to have to add lithium chlораte's molar mass by using the periodic table for every 1 mole. And anytime you use the masses on the periodic table, its units is grams per 1 mole. So I can add lithium chlorate together. Lithium 6.94, chlorine is 35.45. There's 3 oxygens here, so 16 times 3. I add that together, I get 90.39. And like I said, if you use the molar masses on the periodic table, its units is in grams per mole. So now I'm in moles of lithium chlorate. My grams of lithium chlorate cancels out. Moles of lithium chlorate, is that what I'm looking for? No, I want oxygen. I'm going to have to use a mole to mole ratio to get to oxygen. I know there are 2 moles of lithium chlorate per 3 moles of O2 of oxygen. So my moles of lithium chlorate will go on bottom so they can cancel out, and my oxygen will go on top. 2 moles of lithium chlorate for every 3 moles of O2. Lithium chlorate cancels out. I'm left with moles of O2. Is that what I'm looking for? No, I'm looking for grams of O2. So I'm going to have to use my periodic table and convert. Well, not even convert, but add together my oxygen's mass. So for every 1 mole of O2, there are 32 grams of O2 because 16 times 2 is 32. My moles of O2 will cancel out. I'm left with grams of oxygen. Plug and chug in your calculator, and you will get 19.8 grams of O2. I have 3 significant figures in my final answer. That is correct. Pretty picture. So let's look at what we're doing, the summary of today's lecture. You are calculating the mass for 2 different substances because you're given a different substance and you're changing it into the other substance and then converting that to that substance, that new substance's grams. Remember, molar mass is always equal to 1 mole. Remember, when you use the masses off the periodic table, it is in grams per mole, grams per 1 mole. That's what makes this so useful in dimensional analysis, because it's always 1 mole. The only time the number of moles is different than 1 is when you're doing the mole ratio step. That's when you're going between 1 mole to another mole using your coefficients in your chemical equation. Any questions? Please ask me or Mrs. Flint.